Okay, hi again everyone. We are still in our statistics class notes, of course. We're now on page 34. We are in section 3.2 and we're currently talking about the empirical rule, which is a rough guideline for understanding about how much data will be within 1, 2, and 3 standard deviations of the mean in a unimodal symmetric distribution. So remember, it has to be a unimodal and symmetric distribution. So for example, let's say the mean daily high temperature in San Francisco is 65 degrees Fahrenheit with a standard deviation of 8 degrees Fahrenheit. And so we're assuming it's unimodal symmetric. We want to find the temperature ranges for 68, 95%, and 99.7% of the data. So for 68% of the data, so the mean is 65, the standard deviation is 8. So we add and subtract one standard deviation, 8. So 65 plus 8 is 73. 65 minus 8 is 57. So 68% of the days in San Francisco should be between 57 degrees and 73 degrees. For 95% of the data, we add and subtract two standard deviations, or 2 times 8, which is 16. So 65 plus 16 is 81. 65 minus 16 is 49. So 95% of the days in San Francisco should be within 49 degrees Fahrenheit and 81 degrees Fahrenheit. 99.7%, or almost all of the days, should be within 3 standard deviations of the mean. So 3 standard deviations is 3 times 8, which is 24. If I add and subtract that, 65 plus 24 is 89. 65 minus 24 is 41. So almost all of the days in San Francisco, 99.7% of them, should be within 41 degrees Fahrenheit and 89 degrees Fahrenheit. So using the empirical rule then, let's decide whether it is unusual to have a day when the maximum temperature is colder than 49 degrees Fahrenheit in San Francisco. Now, here's a rule of thumb. Put a star by it. Rule of thumb. Anything more than 2 standard deviations from the mean is going to be considered unusual. That's our rule of thumb the rest of this class. Anything more than 2 standard deviations from the mean is unusual. So, colder than 49 degrees is unusual since it is more than 2 standard deviations below the mean. Now, z-scores are another way for us to tell how far above or below a score is, a data point is below the mean of the data set or above the mean of the data set. So it measures how many standard deviations an observed data value is from the mean. Now, how do we interpret z-scores? So for example, if it's a positive 1.5, that means that the observed data value is 1.5 standard deviations above the mean. So all of our x values, all of our data values, our x's, will have a z value now. And we're going to convert each x to a z value. And I'm going to show you how to do that. Each x will be converted to a z-score. Let's say 1 was converted to 1.5. That would mean it would be 1.5 standard deviations above the mean. A z-score of minus 1.5, the negative sign, would mean that it's 1.5 standard deviations below the mean. So here's an example here of this was height in inches for a sample of men. So this is a dot plot of it. Pretty unimodal and symmetric. Very good. Okay, so this is the x values, right? 61 inches, 79 inches. We got dots anywhere in there. Now, 1 standard deviation above or below the mean is going to be converted to 0 for a z-score. So every mean of the mean of a data set will be converted to 0. Now, 1 standard deviation above, the standard deviation is 3. So that z-score will be a 1. 1 shows you how many standard deviations above. 76 is 2 standard deviations above, right? If the standard deviation is 3, that puts it at 76. So that z-score would be 2, etc. Now, if we're looking for unusual values, how many men would have z-scores greater than 2? That would be unusual. That would be unusually tall men. Notice that there's only 2 dots up here that were unusually tall. Z-scores of greater than 2. How many men would have z-scores less than negative 2? Again, that would be unusually short. So that would be these 2 guys. There's also 2. So make a note, z-scores allow us to compare observations from different distributions because it just gives you how many standard deviations above or below the mean is, and that allows us to look at different distributions and actually compare data values that way.